we're going to look at our last chapter, last part of chapter 5. So we're going to look at harmonic motion. There's a fair amount of overlap in this and things that we've touched on earlier. So don't be surprised when you think, well, we've covered that. The answers are we probably have. But the types of things we're going to do are, if someone gives you an equation like this one, can you find not always all 5 things, but like 3 out of the 5 here, and then draw a sketch of it using Desmos. And as you can see here, a big bunch of questions all about that. There is a new addition to the family, and it's this guy called phase, and I'll talk about that in a few. And then you have a bunch of questions where you are given some of this information and you're asked to create an equation and then graph it. So you get an equation, right? You're given an equation, tell me these 5 things and graph it. You're given these things, make the equation and graph it, right? So it's a bit like A to B or B to A. And that is the vast majority of the section. And then we've got a couple of little tidy up things. There's an application one, question 12. There's a weird formula called damped oscillation. We've got one of those. And we have a phase shift creating formula, which is really just a version of this, but a little bit different. So let's begin.
Professor?
Yes.
If the B is factored out in this case, would the phase be B times C?
So if I'm picking up correctly, if you got a question that was written like this, and I think that I'll make it a different number so that we have things going on. So if you factored out, or if they factored out a 2 like this, like that, and you're saying, is the phase, this new guy, 2 times pi upon 6, which would be what, pi upon 3? Is that what you're thinking?
Yeah.
You are bang on. That's exactly what it is.
Okay. Thank you.
Okay, so here's a question. Here is a pretty standard sine stroke cosine function. They're the only 2 you're going to do this with. And we've got amplitude, we've got the period, we've got horizontal shift, we have the phase, and we have the frequency. So in this question here, light to green, yeah. A is 10, so the amplitude is 10. And remember, isn't the amplitude always positive? So it doesn't matter if it's negative 10 sine x or plus 10 sine x. The amplitude's 10 in both cases. Now, if you want to get the period, isn't the period connected to this number here? So it's going to be 2 pi divided by, in this case, 2. So the period is pi. And the period is always positive. So if you get a weird question where that's negative 2x or negative 4x, the period is still going to be positive pi or pi upon 4, whatever it might be. Now you've got the horizontal shift. And the horizontal shift is this guy divided by that. So that's C divided by B. That is really just a placeholder, that plus. What I don't care if that's plus or minus, we figure that out later. But can't the horizontal shift be positive, and it also can in some questions be negative? And if this is negative, isn't the horizontal shift positive? Now, I don't include that in the formula because I think you end up doing like a double negative. You end up using the formula and then you go and change the sign anyway. So you should either use one or the other. So I basically just don't care what that says, plus or minus. I just use that number. And then once I get the answer, I go back and look at the question and say, oh, somebody take away a thing means a positive shift. Something add that would mean a negative shift, right? And that's how you would do it. Now, there's a guy called phase, which is the new guy in town. And the phase in this case is just C, in the sense that if that's negative, this is positive. Now, if this had said 2x plus pi upon 3, wouldn't the phase be negative pi upon 3? Okay. So negative, positive phase shift, positive, negative phase shift, right? Just, in fact, it's the same rule for these two, right? So these two are always going to be the same sign. This one and that one, right? They're both going to be positive things and they're both going to be negative. And then we have the last guy. Sometimes you're asked to find the frequency. And if you want a formula for the frequency, it's basically take the period and turn it upside down. You see that? Because 1 over the period is called the frequency. How many times it repeats itself in 1 second of time. So in this case, the B is 2 divided by 2 pi. So in this case, the frequency would be a pretty boring 1 over pi. So far, so good. Right.
I have a
A lot.
question.
Yes.
How come with the horizontal shift and phase, they're always going to be both positive or both negative?
Right. When you take a sine function, so many x, and you do a minus pi upon 3, a negative, which minus here, means that you're moving it to the right. And if you move things to the right, it's a positive number. When that's a plus, that means you're going to move the thing to the left. And when it's left, it's negative number. So that's basically a rule. That's what you do. If you don't like rules, here's an analogy. If you had y equals x squared, and I asked you to draw y equals x minus 3 squared, do you see that negative actually transfers into a move to the right? 3. So that's the same kind of thing as having a negative, right? Negatives mean move to the right, and you tell people moving to the right by saying, in this case, it would be what, +3 would be their shift.
What if
But
B
let's
is
say B is a negative number, then wouldn't the horizontal shift be a negative?
Yes.
And the phase is a positive.
No. Okay. The one
Phase
I've
and
got is,
horizontal
yeah,
shift are always the same sign.
yes, they're always the same size. Sign, correct. Right. If I pick you up correctly, let's suppose I was going to do that one, right? So I'm changing as little as possible. Right. Now you might say, well, you told me that when that is negative, the answer is positive. Well, that's only true when this is positive. Right. So that would be moved to the right. So the answer would be positive. So far, so good. Okay. Now, what would happen if you make this negative? Well, you have to do a lot more work. And the good news is that they hardly ever give you that. But if you rewrite it in this format, can you see that that's actually disguised positive? And what does positive do? That moves it to the left. And therefore, in this case, negative pi upon 6 would be your answer. So there are two possibilities. Since the vast majority of questions are going to be 2x, 3x, and 10x, then essentially what I've done here works really fine. The minute you see a negative here, then you have to kind of take that question as a special case and figure it out that way.
And then the phase would be negative pi over 3, right?
Yeah, whatever. Yeah, exactly. So, right, so you would look at that in, you know, depends on the question, plus or minus, but yeah, whatever the horizontal shift is, plus or minus, then so will the phase be the same, plus or minus.
So it doesn't matter, like in the first question, if it was a positive pi over 3, then the horizontal shift, even in that first question, would be say a negative number.
Yes.
Okay.
So the rule is, if that's negative, it's a positive number. If that's positive, it's a negative number. It's a kind of switcheroo thing. It is what it is. Unfortunately, I wish it was a more straightforward rule. you know, like whatever that is, your answer is that, but it's kind of whatever that is, your answer is the opposite of. So let's show you the sketch part. So very often in these questions, you get to sketch the thing. So the one that we did, the first one that we did before we did those, you know, other versions, looks something like this. There we go.
2x.
Oh, darn it in space. Thank you. There we go. And there is my function. It's kind of pretty. Now, one of the things that you have to kind of do is that you'll get 4 pictures. One of them will be that guy, but you have to adjust the windows, especially the x-axis, to suit the choices that they've got. So let's pretend that in this case, they gave you a picture that was from 0 to 2 pi, right? So if it was going to go from 0 to 2 pi, you put a little curly bracket here. You go 0 less than or equal to x less than or equal to 2 pi. You then put a colon in, and you finish with a little curly bracket thing. And now when I zoom out, you see only the piece that will appear in the screen is there, right? And so if I kind of zoom in, you see we've got that. It's kind of nice. Now, if you wanted the scales to have versions of pi, like I have here, hit the little spanner system, put in whatever number you wanted to start at. Let's say it was 0 to 2 pi. And if you noticed that the labels were in multiples of, say, a quarter pi, they make the step the basic little unit that they're using. So if you see them go quarter pi, 2 quarter pi, 3 quarter pi, then put in a quarter pi. And when I click out here, there we go. Can you see, we see the whole thing. And then you go hunting for your 4 pictures, one of which better look like that guy. Yeah. And little pause. Are we good with what we've done? So if I give you this guy, do you feel comfortable about finding all of these 5 fellas with a little plus minus issue, and then drawing what a picture would look like using Desmos, and then picking the right one, you know, the one that looks like yours from a set of 4? We good? We got nods? We are good. Okay, let me try another one. How about question 3? So it's going to be y equals negative the cosine of 0.3t. Okay. And they want to know the amplitude, period, and frequency in this case. Okay, what number is the amplitude in this question?
1.
1.
Now, if you want to find the period, isn't it going to be 2 pi divided by a really ugly 0.3? So I've got decimals and not decimals, normal numbers mixing here. So 2 divided by 0.3 gets me that guy, but I want the answer to be a nice fraction. So math button, choice 1, we'll take our answer and make it a fraction. And what they're looking for here is 20/3, right? And now, if you want the frequency, isn't the frequency, well, here's the formula for it, but isn't the frequency also 1 over the period? So if you've already found this guy, can't you just turn him upside down? And that's a quicker way of getting the frequency, right? So you don't have to do any weird calculations. Just take this answer and make it a reciprocal. And then you would take this guy and you would be finding its sketch, and there are 4 choices, and you set up the window. I'm looking at them, but they go from 0 to 20/3 pi. So that would be your start and finish. And you can adjust the markings, whatever you want to suit it. And you will get a picture. And we are done. Right, let's try my next one. Question 5. So y is negative 0.5 cosine of 0.75 t take away pi upon 3. So it looks like we're mixing and matching decimals with fractions. And so we'll make sure that all our answers when we're finished are fractions. So amplitude is A, 0.5. The next thing they want is the period. And that's 2 pi divided by B. So it's 2 pi divided by 0.75. And then when I'm finished, I'm going to make that a fraction. So I just do the number part, the 2 divided by 0.75, which is this guy. And then math, choice number 1. And the answer I got is 8/3. So there is the period, and they want the frequency again. And if that's the period, if it helps, can't you write that guy that way? So when you turn it upside down, it's a little bit clearer where the pi goes. Right. So that might be a better form than that. And you got your frequency, and you draw your sketch. Are we good with that?
Still copying it down.
That's not a problem. I'm going to do this one including the sketching in decimals. So it's 3, the cosine of 4/3 t at 3/4. And they want the amplitude, they want the period, and again, they want the frequency. The amplitude is 3, the period is 2 pi divided by 4/3. There's 2 divided by brackets 4/3. And that, when you turn it into a fraction, is 3/2. So the frequency would be that one. Now, if you look really carefully, when I did this one, it was 2 divided by 4/3, and I put brackets around the 4/3. Here's 2 divided by 4/3 without the brackets. Already kind of looks wrong, and it definitely is wrong. You see, the answer's 1/6. So make sure that when you're doing a fraction or a number on the top divided by a fraction, you put a bracket around it. And that way you get the right answer. Okay, so I'm going to take this guy and we're going to do a Desmos sketch on it. And I am looking at the pictures that I've got to choose from. And there's 2 different scales going on. So let me find Desmos. Desmos is left the building. Here we go. Try it again. There we go, found it. Right, so one of these pictures is using a scale of, well, let's do this one, 0 to 3/2. So I'm going to go 0 to 3/2 pi. And the function that we were doing was 3 cosine 4/3 we'll call it 4/3 x just to make it easier. And 3, turn it in space, 3 quarters. 3 cosine, good. 4/3, yep. And it's a plus, not a minus, okay. And that's important. Okay, there's the guy. If I take this function and maybe make it a little bit bigger, I don't like the vertical scale, so I'm going to go in here and just change it to 3 and -3. Okay, so that's what the guy looks like. Okay, so that's from 0 to 3/2 pi. Now, if I go and show you the question, can you see that 2 of the pictures go from 0 to 3/2 pi? Are you seeing what I'm saying? You're saying 4, right? Now, that guy kind of starts low and then comes up high. None of those two work. So I'm going to go the 9/16 plus, and then that guy. So it's a weird scale. So it's -9/16. So on one side. That's probably enough to see it. Right, so if I move this guy a little bit, right, maybe shrink it back a touch, it has this shape. Now, we go and we look at the questions. It's that one. Okay. Right, see how that one is a little bit to the left? Oh, it could be that one. Oh, it's that one, isn't it? And that's just because the height was 3. So these look the same, but the heights are different. This goes to 1 and that goes to 3, and the amplitude was 3. So let's return back to our notes and fix something. Forget that. I thought that I'd actually written down, in this case, the horizontal shift. If I had written down the horizontal shift, wouldn't the horizontal shift be C divided by B, 3/4 divided by 4/3, which is 9/16. And since this is positive, wouldn't this be -9/16? So can you see why we started at -9/16? Right. Doesn't that mean go left 9/16? Any questions about that one? Are we good? So we are now moving on to the second type of question. What we've done right now is, if you give me a function, can I find guys like this? And then can I graph them? That's kind of what the first 7 questions were concerned about. We're now going to kind of turn that question on its head. And that's going to be, if I give you information, can you create one of these guys? So let's find one. This is question 8. Just looking for one of my sheets of paper. Under here. How could I lose a little piece of paper on a desk? There we go. This is the guy I want to use. So in this question, we're being asked to find a essentially a function using the sine guy, right? So it's going to be a sine bx plus c, right? They want us to find the equation. And the information that I'm being told here is that the amplitude is going to be 8 and the period is going to be 3. And they don't phrase it in a very clear way, but what they tell me here is that the horizontal shift is 0. And the way they do that is not by just saying the horizontal shift is 0, which I wish they would, is that they say this: assume that the displacement is 0 at time, oh, I better change my variable, at the time t equals 0. So that should be a t. So I know the amplitude, I know the period, and I know the horizontal shift is 0, and I know it's 0 because of this. So I'll start off with the generic version of all of these answers. And then we'll work from there. So if you tell me that the amplitude is 8, would you agree that the answer has an 8 there? Right, if you tell me the amplitude's 2, I'll put a 2 there. Now you tell me that this guy is 0, so I'm putting a 0 here. So all I've got left is some number t, right? I'm trying to find that value of b. So if I look at this formula here, and I know what the period is, right? And I'm trying to find the missing value for b, and it's just a rearrangement of this formula. Isn't b then 2 pi divided by the period? So if you take this formula and basically rearrange it so that it becomes b equals, these two essentially switch places, and b equals 2 pi over the period. So that makes b equal to 2 pi divided by the period, which is 3. And so what we get here is 2 pi over 3. And then you would make it look pretty. And that would be your final answer. Technically speaking, doesn't that also work? Doesn't that have an amplitude of 8? And if you calculated a period of 3, and there is no horizontal shift. But you're going to pretend that that option's not on the table. That way you can have this answer, and that's the one where the sign's expected. So we'll assume that the value here is positive unless there's some other indication that they tell you that makes you believe that it's a negative number. And then you go and sketch it if you need to. So let's try 10. In question 10, you're told that it's a cosine this time. So it's going to be A cosine BT plus C. And they're telling you, assume that the maximum displacement, assume that displacement is at its maximum at time t equals 0. So that's why I know it's a cosine, and why I also know that C is 0. I'll write down the sentence that tells me that. It says, assume that the displacement is a maximum at t equals 0. If you look at a sine function and you look at a basic cosine function, and we're assuming that the phase shift is 0 in both cases, can you see that for a cosine function, it reaches a maximum value at t equals 0? So that's why I know it's a cosine. So I should be able to answer the question as soon as I find out the missing fellas. Well, the missing fellas are that the amplitude is 2 and that the frequency is 4. And actually it's 4 over pi. And the units for frequency are hertz, which basically are cycles per second. But don't let that disturb you. Focus on these two. Now, since the amplitude is 2, and I know it's a cosine, and I know C is 0, I basically just got one missing value, this fella. Now, they have told me the frequency. So if I look at the connection between B and the frequency, do you see it looks like this? So this is my side working. The frequency is B divided by 2 pi. And I want to know B. Now, if you rearrange this formula, B is 2 pi times the frequency. So it's going to be 2 pi times the frequency. And that ends up being 8. And that's how I figured that that was 8. So we are using these formulas, but we are using them very often to find a different thing. Normally you would use this formula or that one to get the period or the horizontal shift, or in this case, the frequency. But we're going to rearrange it to find out what B is equal to. So maybe I should write that down. B is equal to 2 pi times the frequency. And if you rearrange this one, B is equal to 2 pi divided by the period. Essentially, in these questions, we're after the value of A, B, and or C. How are we doing? Okay. Right. So let's do one. Let's suppose that you know it's going to be a sine. In this question here, I'm going to tell you lots of stuff. I'm going to tell you that the phase is 10. I'm going to tell you that the amplitude is 3, and I'm going to tell you that the frequency is 100, and that it's a sine function, and that C equals 0. So Y is going to be 10. That's not. Y is going to be 3, the sine of Bx plus C. Okay. If I know that the phase is 10 and it's positive 10, I can use that right. Positive 10 gives you negative 10. Right, this number with nothing done to it is your phase. Guess well, apart from putting a negative in. Now to get B, don't I need to use this one since you tell me the frequency? So B is 2 pi times the frequency, which is 100. So that ends up being 200 pi. And there is your formula using the given information. And you could sketch that and figure out what it looks like. Are we still good?
Why did you write sine and then C equals 0?
I'm telling you that in the story that the function's a sine, which is kind of obvious because what I've written there, but pretend it wasn't. And that C is 0. And they tell you that they assume that the displacement is a minimum at t equals 0. That would how I know it was a sine, because they mentioned minimum, and 0, 0. That's why that is there.
But isn't C 10?
Oh, the phase is 10. My apologies. Yes.
So then C would be equal 10, not 0?
Yes, in this case.
Okay.
Yeah, that was a different combination. I was still thinking of the earlier ones. Right, there's an application coming up. So I'm going to show you what it looks like. Here we have an oscilloscope, some sound wave, and we are going to take this and try our best to figure out what the answers to these questions are. So here goes. This is question 12. Looking at the shape, can I make this bigger? I want to make this bigger. Maybe even make it a touch bigger. There we are. That's probably as big as I can make it. Right. In this picture, we're going to be finding things like, well, the first thing we're going to do is we're going to find the maximum voltage. Would you agree that the maximum voltage is just another disguised way of saying, tell me the amplitude? And darn it in space, the answer is there. Oh, well, I just can't do it now. That's fine. If you look very carefully at the side here, that line there is 0. Right? And if you go through these, I'm assuming that there's a line there. So 10, 20, 30, 40, 50. And so it's going up in 5s. So that's why this is 45. So the maximum voltage is the highest it goes up to, right? So in this case, 45. Now, the next question, I don't want to scroll down because the answer's there. But the next question we're going to ask you to find is the frequency. Now, the frequency is how many times the cycle repeats itself in 1 second. Now, the only number that they've told me is 0.1, which is here, right? So if you look at this guy, you cycle once, you cycle twice, you cycle 3 times, you cycle 4 times. Would you agree that's 4 cycles in 0.1 of a second, right? Goes up and down and back. 4 of them in 0.1 of a second. So how many would it do in 1 second? If it does 4 in 0.1 of a second, how many would it do in 1 second?
40, right?
Right. 10 lots of 4, 40. So we now know the frequency. Great. So 40. Yeah, good. Now the next question, it goes and says, how many revolutions per second does the armature in the generator make? Well, unless you're into electronics, that sentence doesn't make sense, but it's actually the same number as the frequency, right? Because what happens is the little thing turns, and each time it turns, it causes 1 cycle of the wave. Now, the last piece of the puzzle is that, oh, before I go, is this going to be a sine function or a cosine function?
Cosine?
Agreed. What feature kind of pushed you in that direction? Why is it a cosine and not a sine?
The maximum of 45 is at 0.
Does that make sense to everybody? Right? That's how cosines work. See that little guy there, if he'd started here, can you imagine the origin was here, right? So it started at 0. Wouldn't this become a sine function? Because they look very similar, don't they, unless you've got a clue like that. Can we also assume that the phase and the horizontal shift are 0? Because there isn't any kind of, little wiggle room, right? So put that package together and let's see if we can get the equation of what that would look like. Well, I know it's a cosine. We already agreed on that. I'm going to do that pt plus c thing. That's 0. And that's a cosine. And we got that just by looking at the picture and noticing that it started here, right? That's how I know it's a cosine. So it's going to be an amplitude of 45, a cosine of so many t plus nothing. So I only need to find this guy and we are ready to go. Well, if you tell me the frequency is 40, can't I get this missing b, right, by just saying 2 pi times the frequency? And the answer I got would be 80 pi. Bingo. There's really only 2 numbers that you needed to know, what the amplitude is and what the coefficient of t would be. Have we any questions? Do you feel good about that?
Yeah, for displacement, is displacement an absolute value?
I'm trying to think what your question is. Is displacement an absolute?
Always positive? Like if you
No, displacement could be negative.
So if you had something that was a cosine and it said the displacement is at a minimum at t equals 0, then it would have like a negative a.
Oh, if it was a cosine, yes.
Yeah. Okay.
Yes. That's quite messy. So the good news is I don't think there's a question like that. But if there was a question like that, that would have been the answer.
Okay.
Are we going to do that? And what is left? There is not enough time. Tomorrow, I will show you an example of what's called a damped oscillation. Before we go, so while I'm doing this, put in your last name. A normal oscillation, the ones we've been doing, are like that, right? You go up and you go down, and that height could be anything, right? It could be 3 and -3 and everyone's happy. But in a damped oscillation, it looks more like this. It goes up and it goes down, and then it's not quite as much down and not quite as much up and not quite as much down and not quite as much up. And it kind of peters out like nothing. Can you imagine a ball bouncing? You know, each bounce, it's not quite as high or as low as it would be before. These kind of things are called damped oscillations, and they have a formula that looks very like the kind of guys that we've been doing. And they even have a 5, or in this case, I guess, a 3. So what makes this bit dissipate? You have a new guy, e to the negative, what letter have I not used? D. So you'll get 3e to the negative 0.17t, the cosine of 4 pi t. This piece here is what makes it damp, right? If you make this negative, and by the way, it's always negative in stories that are damped. And if this is a bigger number, then it, you know, the ball hardly bounces at all, right? Like a dead fish bounce, right? It goes normal, then almost nothing, right? And if this number is quite small, then you get lots of bounces because it only loses a little bit of energy each bounce. And that's what we call a damped oscillation. And when we see you tomorrow, we do one question on them. And that's pretty much all we do. So you won't get to see a lot of those. Okay, I think that is us good for today. So is there